okay? And what we're going to do now is we're going to go ahead and practice, right? What I'm going to do is I'm going to go over, there's 7 of these questions on practice number 1 through 5, because we're only going to do the first 5. There's actually total of 8. We'll cover those next time, okay, when we actually are doing this. And I'm going to do the first 3 for you to show you guys how to do them. And then you guys are going to practice doing the next 4. The answers are there. So what you can do is you can check your answers against the PowerPoint. But I want you guys to practice because that's the only way you're going to get proficient and know how to do these. Okay. So let's go ahead and maybe not. That's not going to work. Okay. I'm going to go ahead and go to our LFD here to do that. Okay. Okay. So let's take a look at the first question. The question is estimate the total AMUs, or how many AMUs. And the first one is 2 atoms of iron, right? So you have 2, oops, this, yeah, 2, right, atoms, Fe. I usually don't write the word up, all right? This is what you want to do always. Write down what's given to you. Number 1 says 2 atoms of Fe. So write down 2 atoms of Fe, put 1 underneath it. Okay, then you want to go, okay, is there a relationship between what I want and what I'm given? Is there a relationship between AMUs and atoms? Yeah, it is the atomic mass, right? The atomic mass. We know, and how do we get the atomic mass? We go to the periodic table, right? So we look up iron. Sorry about that. Let me go ahead and move this out of the way. Periodic table here. Let me go ahead and I have to stop the share here. Sorry about that. Stop the share here first. Go over to periodic table. Sorry about that, guys. Let me get this done for periodic table. All right. Then let's go ahead and go back to this. Okay, let's go ahead and do this. Share. Share. There you go. That's better. All right. So where do I get the answer here? I go to the periodic table, right? And I look up iron. Where is iron? Iron is over here. Here you go, right here. Iron, Fe. It's 55.84. You know what I'm going to do, guys? I'm going to just round it off to the nearest whole number. You can do that also just to make your calculations easier. When I give you guys a test and you need to choose the right answer, the answers will not be real close to each other. So that way, what you want to do is you want to get whatever answer you get, pick the closest one to it, because that will be the right answer if you did it right. Because I'm not going to have answers so close that if you just do it by rounding things off, it's going to make things wrong. Okay, so I'm going to go ahead and round this off to 56 AMUs per atom. Right, there's 56 AMUs per every atom of Fe. Right, so I go back to here. So I know that the relationship is there are 56 AMUs of Fe for every atom of Fe. Right? And again, I got that from the periodic table. Atoms of Fe go away, leaving me with AMUs of Fe, and that's what I want. and that gives me 112 AMUs. Okay. There you go. Now, the second question is, what happens if you're given 3 atoms of copper? Again, put them one underneath, right? Again, you do the exact same thing. You look up copper. Copper, right? Where's copper? Copper is right here. And it is 63.546. So let's round that off to 64, right? 64. So we have 64 AMUs of copper for every atom of copper, right? Atoms of copper go away. Multiply that out. That's 12. 3 times. That's 12, 18. So it's 192 AMUs of copper. All right. The third one is I have 155 atoms of hydrogen. Right. I don't really have to look that up, but I'm going to show you guys anyway because I know it's 1.01. Here's hydrogen right here, and it is 1.01. Right, grams. I'm just round that off to 1 gram per AMU, right? Or 1 AMU of hydrogen for every atom of hydrogen. Let's round that off, and that ends up being 155. I believe on the answers they used actually 1.01. It came to 157. So, oh, sorry about that. Copper. What? Hydrogen. Okay, so there you go. So that's how you do the first 3 set number 1. Right? I'm gonna hold this, I'm gonna hold off. I'm gonna go through all 5, and then I'm gonna let you guys do this on your own. You know, take your time doing it to make sure you understand. Right, and you can compare that to there. So just remember 112, 92, 155 for that. So I'm going to stop the share. Stop the share here. Go back over to our PowerPoint. All right, so let's go ahead. All right, so let's take a look at the answers. So the further one, 112, yep, that's what we got. 191, we got 192, that's close enough. And then we got 155 instead of 157, that's also close enough, right? Now, because I rounded the numbers off just to make things easier. Now for the next 4, you do have the answers, okay? But I want you to try setting the problem up, calculating it yourself, either use your phone or if you have a calculator, use a calculator to get those numbers and you can check yourself. Okay, so that's set number 1. Let's go to set number 2. Now what you're given is you're given AMUs, but you want to find the number of atoms. It's the reverse process, right? Now, before we multiply, most likely if we're going to reverse the process, we're going to end up dividing. Okay, so let's go ahead and go over to our, go to our LFD again. Oops. Again. Share screen. And let's get rid of this. This here. That there. Okay. So the first one is you have 201.80 AMUs of neon. Right? The one underneath it, right? So now I want to know how many atoms, right? So we use the same thing. We go to our periodic table. We look up neon, right? Here's neon over here, right? Neon is 20.180. I'm just going to use 20, right? So I'll go back to here. So we know that there are 20 AMUs of neon. I put the AMUs on the bottom so I can cancel out the AMUs in the numerator, right? For every atom of neon. That gives me the number of atoms, right? Because the AMUs cancel out. So 201 divided by 20 is approximately 10. So let's say this is just 10 atoms. Round off the atoms to the whole number because you can't have partial atoms, right? 10 atoms. The next one is you have 305.64 AMUs of vanadium. You know what I mean? Right? Again, we got to go back to the periodic table. Look up where vanadium is. Vanadium is a metal, and it's not a transition. I mean, it's not a rare earth, so it's there. There it is, right here, vanadium. Okay, and it's 51 AMUs. I round that up. 51 AMUs. All right. So again, we do exactly the same thing. It's division. 51 AMUs for every atom of vanadium. Right? Again, AMUs of vanadium. And that's approximately 30 to 300 divided by 5. And so it's probably about 6 atoms. Okay. And then the third one, we have 7.07 AMUs of hydrogen. Right? And we already know hydrogen is 1. Right? So you got, right, 1 AMU of hydrogen for every atom of hydrogen. That was an easy one. Go away. And that gives you 7, right? Because you want to round to the whole number, 7 atoms. So that is not so difficult. Okay, 10, 6, and 7 is the answer that we got, right? So let's go back to our PowerPoint. Let's take a look. Let's see how well we did on those. 10, 6, and 7. So let's go back. Okay, so let's take a look at the answer. So we got 10, that's right, 6, and 7, right? And then the next 4 I'm going to let you guys do, and those are the answers you should get. Again, you're going to need to go to Google Classroom, download the PowerPoint to practice those. All right. And then that was the second set. Let's go to the third set here. Now this is a little different. Now you're given the grams of an element. And what you want to find is the number of moles. Here's the thing. Is there a relationship between grams and moles? Yes, there is. It's called the molar mass. You know how many grams there are per mole of a substance by using the periodic table, using the atomic weight in grams. All right. So let's take a look at how we go about doing that one. All right. So let's go back to our LFD here. Where we're going to be able to do this. Share this. Okay, let's get rid of this, the one we just did. Get rid of this. Okay, so the first question is, we have 183.84 grams of tungsten. Right? And what we do is we go back to the periodic table. Right? We look at where the heck is tungsten. Here's tungsten. Right? It's 183.84. 184. Round that off. All right? So we go back to our problem. Okay. So instead of saying AMUs, we have 184 grams of tungsten for every mole of tungsten. Right? Because that's the relationship. Grams is with moles. AMUs is with atoms. Okay? So if this was AMUs down here, it would be 184 AMUs. Instead of being moles here, it would be atoms. Right? The grams go with moles, the AMUs go with atoms. right? Molar level, atomic level. Get rid of this, that will give you the number of moles, and that's actually 1, right? Because I rounded this off, if I round the top one off, that will give me 1. So 1 mole of tungsten. Right? Next problem is 13.88 grams of lithium. Again, put that in there. Right? Go back to the periodic table. Right? We look at where lithium is. Here you go, lithium right here. Right? Round that off to 7. Okay? So we'll take 7. We'll take 7 grams of lithium for every mole of lithium. Okay? 7 grams go away. That's approximately 14 divided by 7, so this is like 2 moles. Oh, not LI, sorry about that. Not lithium, it's lithium. LI. Okay. And then the third one is 13 grams of chromium. Right, look at chromium now. Chromium is a metal, and that's 52. Right, here's chromium right here. 51.996, that's 52 grams. Go back here. You got 52 grams of chromium for every mole of chromium, right? Grams of chromium go away. Right? So we go, okay. 13 will actually go into 52 4 times, because 4 times 13 is 52. So I can cross this out and make this a 4. Now, what is the decimal point for 1 over 4? It's 0.25. So therefore, this is 0.25 moles of chromium. So there you go. 1, 2, and 0.25 is the answer for the first 3. Okay, so let's go back to our PowerPoint here, double check our answers. Okay. That's 1 mole, like we said, and be 1, 2 moles, and then it should be 0.25. There you go. And then I want you guys to do the next 4 on your own to get those answers. Okay. If you don't get those answers, you can come in during office hours or ask questions during class. Okay, but I need for you guys to practice because that's the only way you're going to learn how to do this. Okay, the 4th set is we're going the other way now. Now we're given moles, and I want to get the number of grams. Well, we divided previously when we went from grams to moles. Now, most likely, we're going to have to multiply. It's the opposite. Okay, so let's go ahead and go to our LFD again. Oops. Let's go and do this stuff. Need it. Just finish it. All right. So the first one is you get 5 moles of platinum. One underneath, right? Again, and you want grams. So the relationship between grams and moles is the molar mass. Go to the periodic table. I'll tell you guys right now, there's some of you guys I can see in here aren't listening. You're going to have a whole lot of problems once this happens, when you actually have to do this. This is what's going to happen. If you don't listen, you're not paying attention now, your grade's going to drop. It's going to drop at least 1 grade. At least 1 grade, maybe 2. So if you have a C right now, you'd be failing the class. There's just no ifs, ands, or buts about it. Okay? You have an A, you end up getting a B. Well, actually, you end up getting a C. Maybe. Okay? So I suggest you guys don't play around, because I told you, I warned everybody, this is the hardest part of the course because of the mathematics. Okay? There you go, platinum, 195 grams per mole. All right, so 195. So go back to here. All right, so we got 195 grams of platinum for every mole of platinum. Now I can cancel out the moles, right? So 5 times 195, let's see, this is going to be 25, that'd be 975 grams of PT of platinum. Okay, so you do that. For number 2, you get 2 moles of sodium. Okay, again, go to our periodic table, look up sodium. Sodium right here is 23, so it's 23 grams per mole. And again, just round things off. So that's 23 grams of sodium for every mole of sodium. Away, 2 times 23 is 46. 46 grams of sodium. The third one is 2.5 moles of tungsten. 2.5 moles of tungsten. All right, and then we look at tungsten again. We did that once before. Tungsten's right there. It's 184. All right, 184. So it's 184 grams of tungsten for every mole of tungsten. See how quickly these can be done? They're not hard, but you just got to know what to get when and where. So 2.5 times 184. I'm going to take out my calculator to do that because I'm doing that in my head. All right, 184, 5. And we get 460 approximately. It's probably a little less than that because we rounded it off. All right, so there you go. 975, 46, and 460. We'll take a look at our PowerPoint here. Let's stop the share. Go back to our PowerPoint. Okay, take a look. 975, that's what I got. Round that off, we got 46 and 460 like we had before, okay? And then you guys are to do the next 4 on your own to try to get at least close to those numbers. As long as you're close, you're okay, as long as you're rounding off and things are looking okay. So now the last set for today is we want to find the molar mass of the following elements. Now, how do I get the molar mass? I just add things up, add the weights up on the periodic table. So let's go ahead and go to our LFD again. Let's get rid of this stuff. Let's just did that. Okay, so first one is H2O. All right, it's H2O. Okay, we want to find the molar mass. Well, all we do is add up the individual parts. Well, if you look at H2O, there are 2 hydrogens. Right, there's hydrogen and there's oxygen. For hydrogen, there are 2 of them. Right, for oxygen, there's only 1 of them. Then we just look at what hydrogen is. Well, I already know hydrogen is going to be 1, but let me just show you. Right? Look at hydrogen, it's just 1. Okay, oxygen. Oxygen is, round that off to 16. Okay, so we know our hydrogen is 1, oxygen is 16. This 2 times 1 is 2. 1 times 16 is 16. So this ends up, when I add these 2, ends up being 18. So therefore, hydrogen is 18 grams of hydrogen for every mole of hydrogen. So that's the molar mass of H2O. H2O. Sorry about that, not hydrogen. H2O. Of water. Not just hydrogen. Okay. Next one is KCl. Potassium chloride. Right? Well, there's only 1 potassium and there's only 1 chlorine. Well, that's easy. All right, so we look at potassium. We go to our periodic table. Potassium is right here. It's 39. And chlorine is right here, which is 35. Right, so we got 39 and 35. here. We got 39 here, 35 here, right? So this is 39, and this is 35. Add those together gives me 74, right? So therefore, there are 74 grams of potassium chloride for every mole of potassium chloride. So that's the molar mass of potassium chloride. Next one is a little trickier. We have calcium nitrate. NO2. Okay. Now, you got to watch the brackets because the brackets multiply whatever is on the inside. So when we're looking at this particular compound, there's one calcium, right? There's actually two nitrogen because there's one nitrogen inside, but then you have to multiply by the outside, which is 2. So their nitrogen is actually 2. And for oxygen, there's 3 on the inside of the bracket, but then you're going to multiply by the outside. So that ends up getting 6. So now you got to look those up. Calcium. Calcium is 40. I write that back down. Times 40. That gives you 40. Nitrogen. Look up nitrogen is over here. That's 14. So we put 14 here. And then oxygen, I know it's 16, but I just want to show you anyway. So there's oxygen, there's 16. All right, so you multiply this by 16. This gives you 28. 6 times 16 gives you 96. So this gives you a total of 14, right? That's 5, 7, 9 is 16. So it's 164. So therefore, there's 164 grams of calcium nitrate for every mole of calcium nitrate. There you go. So 1874 and 164 is your answer for the first 3. So let's go back to our periodic table. Not periodic table, our PowerPoint. All right. Let's go ahead and share our PowerPoint back. Okay. Let's take a look. Yep. 18, 74, and 164, right? Like we said. Right? And then the next 4, I want you guys to do. Okay. Now, I'm going to go ahead and stop the presentation now. And what I need for you guys to do is practice. That's the only way you're going to be able to do this. So those people that are online, I want you to, well, people that are in classroom right here, what you need to do is you need to go to the PowerPoint in Google Classroom, take out some paper and pencil and start practicing those problems. Set number 1 through 5, and then, and each in one of those sets go 4, 5, 6, and 7, because I already showed you how to do the first 3. See if you can get those answers. If you can't get those answers, then come see me, or for those of you who are in here, you can just ask me questions. For those of you who are online, try those problems, practice those, the next 4 on each set. And if you can't get those, then you can come see me during office hours on Wednesdays after school. Or if you have a question on Wednesday, you can stay in because I'll take roll and then I'll probably let those people just do what they need to do this coming Wednesday. You can ask me then also, or during class. All right. Any of those will be fine. All right. So if you don't have a question, for those that are online, if you don't have a question for me, then you are free to go to do the practice set. Okay.